Hello! If you've come to this video, it means that you're looking for the trig inverses review. This is going to be part 1. I don't want to make the longest video ever of me going through every single problem, so instead, I'm going to make 3 separate videos of me going through every single problem. So in this video right here, we're going to go over problems 1, 2, 5, 6, and 7. From the review. So again, that's 1, 2, 5, 6, and 7. I've skipped problems 3 and 4. They both deal with trig identities, and we will not be covering that at all on this current test. So let's get started. So this is our, not in the right mode. There we go. Review, yay. Okay, so let's take a look. Problem number 1, that is cosine inverse of negative root 3 over 2. So just a reminder that when we are evaluating, we're only ever going to have one answer, and that's when we start off with an inverse. Now, for cosine, remember we're going to be between 0 and pi. So we're looking in these first 2 quadrants here. Now I know it's not going to be quadrant 1 because this is negative root 3 over 2. So it's going to be in quadrant 2, and it is in fact going to be, we'll pretend that's straight, right there, and that is at 5 pi over 6. So our final answer is that cosine inverse of negative root 3 over 2 is equal to 5 pi over 6. Yay! Let's do problem number 2. Let's see, problem number 2 is sine of cosine inverse of negative 1. So when we're dealing with a composition function like this, we want to make sure that we deal with the inside function first. So let's see, let's take a look. Cosine inverse of negative 1, again, I'm going to draw my unit circle off to the side. That was a very long line. And we're looking specifically right here. I'm looking to see when this is negative 1, and that is actually going to be right along this line at pi. So we can say that cosine inverse of negative 1 is in fact pi. But we're not done yet, because now I need to take that and plug that into my sine function. And we can say that sine of pi, or the y value of pi, is 0. So overall, we can say that sine of cosine inverse of negative 1 is equal to 0. And there's our final answer. Now, this review packet is mostly solving. These are actually the only 2 evaluating problems on here that we will be going over. I've put many more worksheets and textbook problems on Canvas for you to go through, look at with answer keys. If you have any questions about those, please let me know, but I want to let you know that from here on out we will be solving, and solving may have more than one answer. So let's get started. I just want to remind you, for solving as well, we're looking for all of the answers between 0 and 2 pi. So again, there may be more than one answer, and I would also like you to put your answers in solution set. So this is your reminder for solving. We're looking for all of our answers between 0 and 2 pi and in solution sets. So let's get started. Problem number 5 is our next one, because we are in fact skipping problems 3 and 4. Problem number 5 is 2 cosine of x plus 1 is equal to 0. From here, I'm going to subtract 1 on both sides. Divide both sides by 2. Use cosine inverse on both sides. And I get x is equal to cosine inverse of negative 1/2. Now you might say cosine inverse, that only has one answer. That's when we're evaluating. Because we started with cosine, just regular old cosine, we can look at the whole unit circle and not just the first and second quadrant. So now that we're here, I need to find 2 places on my unit circle are two angles on my unit circle where my x value is -1/2, and that is going to be at 2 pi over 3 and 4 pi over 3. So the final answer in a solution set, 2 pi over 3 and 4 pi over 3. On to problem number 6. So problem number 6, ooh, that got real big for no reason. Okay, sorry. Problem number 6 is 2 sine of x minus 1 is equal to 0. I'm going to start by adding 1 to both sides, dividing both sides by 2, and finding the inverse. So x is equal to sine inverse of 1/2. So again, at what angle is the y value, because we're looking at sine, y value 1/2? And that's going to give us the two answers of pi over 6 and 5 pi over 6. So again, I want you to please put your answers into a solution set for me. See, pi over 6, 5 pi over 6. And the last one for this video, this is probably going to be like the shortest video. The last one for this video is problem number 7. So problem number 7 is the square root of 3 times cosecant of x minus 2 is equal to 0. Now, if some of these problems are starting to look familiar to you, a lot of them are in fact on the first homework assignment, so these are just kind of practice again. So here I'm going to start by adding 2 to both sides. Then I'm going to divide both sides by the square root of 3. Now here we kind of have an issue of like cosecant. I don't know what to do with that, but I do know that cosecant is the reciprocal of sine. So what you can do, I'm going to do an extra step here in blue. We can say that 1 over sine of x is really the same as 2 over the square root of 3, right? Cosecant of x is to this. Now, if I want to have sine of x on top, if I want to switch these, I also have to switch over here. So I end up with sine of x, or sine of x over 1, is equal to the square root of 3 over 2. I'm still setting up this problem properly. I still have my sine of x is going to be the same as the square root of 3, and this is, if you want to think about this over 1, the 1 and the 2 are still lined up horizontally. But what we can do now is find sine inverse and say that x is equal to sine inverse square root of 3 over 2. And from here, I think, where does this happen? What angles are our y values? Root 3 over 2, and that is going to be at pi over 3 and 2 pi over 3. So put those together in a solution set, and you have your answer. If you have any questions on these problems, please send me an email and let me know. This is the end of part 1. Go to the next video to watch part 2.